So shall we start or wait?
Yes, please.
Okay, thank you. So good evening, everyone. My name is Advait Goban, and I'm going to be taking this session on introduction to SPSS. So SPSS, its full form is Statistical Package for Social Sciences, and it is widely used in social sciences, healthcare, market research, education, etc. It is used for data analysis, and it is used for data cleaning and data visualizations as well. So today we are going to be exploring what SPSS does, and I'll introduce you to some basic tests that we can use, that we can conduct through SPSS. So first, I'll give you an overview about SPSS interface. The SPSS has basically two. I'll take SPSS for you just to help you visualize. So this is your SPSS interface where you will have two windows whenever you open SPSS. One is the output window. Here you will get all the results, and this is the variable view or the data view where you can do all the analysis and stuff. We will do all the operations from this interface, and we will interpret the result from this interface. This is your basic SPSS interface and output interface. Here, the top in the bottom left corner, you can see two options. One is data view, and another one is the variable view. In the data view, if you click the data view, you will see something like this, where you can see your data as well as the variables. The samples are shown in rows, which I'm highlighting, and the variables are shown in the columns. If you want to open SPSS, you can open, or you can just look here, and we will do the analysis later. Now, right now, I'm just giving you just the overview of SPSS. So one thing that you have to make sure, you have to understand that this is most of the operations are done on the variable view, and the data view is just for the visualization, to understand how our data looks like. Most of our editing, the data processing, happens in the variable view. So here in the variable view, you will get the list of variables, that is the subject ID, blood pressure, group, test scores before, and these are our variables, and this contains the rest of the columns contain the information regarding the variables. So here there are some things that you have to keep in mind when it comes to variable view. The variables, SPSS categorizes variables into three. One is the scale variable, another one is the ordinal variable, and another last one is the nominal variable. Where scale variables are continuous variables, which means it can take any value. For example, height, age, etc. These are continuous variables. This starts from zero and ends at infinity, or it starts from negative infinity, or ends at infinity. So these variables are probably known as the continuous variables. That means it never ends. It is continuous. As I said, examples are income, height, age, etc., which has infinite proportions. Ordinal variables are those variables which we rank, which are meant to be ranked. A classic example of ordinal variable is our Likert scale. Likert scale is something that we use in behavioral sciences to know the people's perception and how people react to certain things. And Likert scale is a common tool of it's an ordinal variable where 1, 2, 3, 4, 5. There are 5 levels where 1 is highly satisfied, 2 is satisfied, 3 is neutral, 4 is disagree, and 5 is strongly disagree. Here, the highly satisfied has higher ranking than satisfied, and satisfied has higher ranking over neutral. Neutral has a higher ranking over disagree, and disagree has a higher ranking over strongly disagree. So here, the variables, the categories in the variables are ordered according to their preferences. Highly satisfied is ranked first, and strongly disagree, or it was meant to be strongly satisfied. It was my mistake. So highly Let me just. Okay. So where the variables are numbered in orders. That means each number represents higher ranking or lower ranking depending on our convenience. But in ordered variable, the numbers should be arranged in systematically, where 1, 2, 3, 4, 5 means 1 is greater than 2, 2 is greater than 3, or 3 is greater than 4, and 4 is greater than 5. And in nominal variables, the numbers are mere placeholders. The numbers does not represent anything. It should not be estimated. It should not be used for direct estimations for mean, median, etc. Here, the nominal variables means the numbers represent some other categories of a variable, and that category is not supposed to be what used for estimation. Especially, for example, if you take the variable gender, I can code male as 1 and female as 2. But that doesn't mean male is greater than female or female is greater than male. We cannot say such an interpretation. Here, 1 and 2 merely represents male and female, and those are placeholders. Those represent another category. So for nominal variables, we cannot go for advanced statistical analysis like mean, median, mode, or consumption, or any other type of inferences. So these are the three types of variables that SPSS uses, and you can see that in the variable view, where in the measures column, you can see that each SPSS automatically accommodates these measures as per your variable, and you can manually edit also. Here, the subject ID, blood pressure is and blood pressure is designated as scale because they have. When you go and look here, these are values that go from. These are values that are decimals and have a continuous have a continuous range. It starts from, as you can see, it has a very higher range. So it starts from a smaller value and it ends at a bigger value. And so this is what we call as a continuous variable. Here the variable, if you look at the variable group, SPSS allocated it as a nominal variable because it has two categories. If you click on value, you can see that it has two categories. One is control and two is treatment. Here, control and treatment are two categories, and it doesn't mean that control is greater than treatment or treatment is greater than control. It just means that one is control and two is treatment. This is the common things that you should know about SPSS variable view. And another thing that you should keep in mind is that always make sure that all your variables are coded in numbers rather than in alphabets. Because if we manually type in control and treatment in the group in the data, then SPSS would not allow us to do any type of inferential statistical techniques. So always make sure if you are entering a categorical variable, you should enter it in numbers. You should enter it in codes. Here, one represent. If you click here, you will see that here one represents control and two represents treatment. So coding 1 and 2 will help us. Coding 1 and 2 will help us easily and analyze in SPSS. So these are the basic things that you should know about SPSS basic interface. And now we will go for some descriptive statistical techniques. So is there any doubts? Hello? Is there any doubts or confusions with this?
Sir,
So that
actually,
No,
how
no, no.
automatically, sir, how automatically that ordinal, how it automatically comes? I mean, you said na that man, yeah.
Yeah, you can. That is SPSS algorithm. They can easily identify the variable's character, and they will automatically categorize it as scale or ordinal or nominal.
So we don't have to ourselves. We don't have to do it. You mean?
Most of the cases you don't have to manually enter it, but if you have a very large data set like with 100 or 1000 variables in your data set, then you may have to manually change it because SPSS does not have that big of a processor or algorithm.
Okay, sir.
Okay. Is there any other doubts? Okay. So descriptive statistics usually means the summary that you provide with the data or the summary of the variables. Here we have 10 variables. So when we run descriptive statistics provides a summary of the variable. Uh, it's often recommended whenever you are doing for any type of inferential statistics, be it cross-sectional analysis or time series analysis or panel data analysis, whatever you are trying to do, it's better you understand the variable first. What type of variables you are dealing with? What type of the range of the variables? What is the mean of the variables? The mean of the variables. These descriptive statistics will provide you with the character of the variable you are dealing with, so that it will help you in deciding what type of analysis that you want to use in your study. uh, Common descriptive statistical techniques are the measures of central tendency, mean, median, mode, and there is also measures of dispersion that are like variance, standard deviation, etc. All these help in understanding whether or not our our variable is suitable for a certain type of analysis. The most common descriptive statistical technique we use is mean and median. Mean means the average value, that is sum of all observations divided by the number of observations. One thing that you have to keep in mind is you cannot use mean at every situation. Mean does not always represent your data in all situations, especially if your data has some kind of skewness or higher variance, or it is not normally distributed. A normal distribution means all the values are centered around the mean, or all the values are spread across the nearer to the mean. Then we can say that mean is a reliable mean, and you can use mean as a representation of your data, of your variable. If it is not normally distributed, that means it has significant outliers. That means you should not use mean as a representation of your variable, because, for example, whenever you're dealing with income data, income is highly skewed. If Because there are a lot of people who have higher levels of income, and there are a lot of people who have lower levels of income, which means that the variable will have skewness either to the right side, either to people who have a higher income, or to the people who have lower income. So when we take the mean income, the average income, or what we call as per capita income, it may not actually represent what actually our data has, but the real level of income. Understand? So if you go and look at the data from US and the Western countries, they will show you that median level of income instead of per capita income, because median level of income actually is free of from this skewness, or the what we call that extreme values. So if the data has extreme values, it's better you go for median rather than mean. Mean is not always a accurate representation of your data. Okay. And the descriptive statistics often provide you with other measures of dispersion, that is standard deviation, that means how much the data deviates from the mean, and variance, that is simply the square of standard deviation. The range explains us is the difference between the maximum and minimum values, and in the interquartile range. Interquartile range is also a measure we use for if there is outliers, or if there is any type of skewness in your data. Okay, so to decide whether or not to use mean or median, or use parametric or non-parametric data, we will look at the standard deviation and the variance. If your standard deviation, or if your variance is higher than the mean, that means your data has significant over dispersion. If your mean value is lesser than variance, or variance is greater than mean, that means there is over dispersion. There is significant variance that in the data, so that the mean is not exactly an accurate representation of your variable. So you should have to go for other types of tests that does not include mean, or simply we will say non-parametric tests will be much better in this situation. So we will go to SPSS. Before that, is there any doubts in what I said? Or
Excuse me, sir.
oh, okay, hello.
So will you please explain what you said now?
Ah. Let me show you an example here. I will take the variable blood pressure. Okay, can you see the statistics here?
Yes, sir.
Yeah, here the mean variable, mean is 123.44, and the standard deviation is 13.625. Okay, if you square the standard deviation, you will get the mean. You will get the variance. When you square that, okay, if you square 13.625, you will get somewhere around 180. Okay, I'll one minute. I'll show you here. Okay, here you simply look at the mean value and the variance. You can see that mean is 123 and the variance is 185. Okay, if the mean value is less than the variance, then that means your model has significant outliers, extreme values. So much so that there is over dispersion in your data. Have you heard about heteroscedasticity? Hello?
Yes, sir.
Sir,
Yes.
Uh, yeah. If you run a normal parametric model on a over dispersed data, you will often encounter with something called heteroscedasticity. So it's advised not to use any sort of linear techniques or any sort of parametric models on an over dispersed data. That's it. That's the inference that you can tell. So from descriptive statistics, you will understand that the variable blood pressure has over dispersion. So we should use that techniques that accounts for this over dispersion. Okay. So someone else has asked. Hello.
So therefore, the ideal case is mean should be greater than the variance. Is it right?
Yeah. 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 Ideal cases mean should be less than mean should be greater than the variance. Then there is
Okay.
there is no issue. Okay. So here we are going to do the descriptive statistics. For descriptive statistics, take your SPSS. I hope everyone have already loaded their data, and you have to go to analyze, go to descriptive statistics, and click on descriptives. I will tell you once again. Go to analyze, go to descriptive statistics, and click on descriptives. Okay. Make sure one thing that you have to keep in mind is descriptive table is only for continuous variables or scale variables. You should not use it for categorical variables, or you should not use it for nominal variables. Okay, for nominal variables we use the frequency table that I will show in the next step. So have everyone got this interface, the descriptive interface?
Yes, sir.
Okay. Then select all the scale variables except the subject. We don't need to know what the descriptors of subject. Select blood pressure before, after, test score, and weight loss. All the scale variables. Blood pressure before, after, test score, and weight loss. And go to options and click select mean, standard deviation, variance, maximum, minimum, mean, standard deviation, variance, maximum, and minimum. You will get this interface from by clicking options. After clicking options, you have to select mean, standard deviation, variance, minimum, and maximum, and click OK. So in your output table, you will get something like this. Have everyone got this table?
Yes, sir.
Okay.
Yes, sir.
Okay. So here our interpretations will be mostly based on the mean and the variance, mean, standard deviation, variance. You don't need to. There are not much to interpret about minimum and maximum. The minimum and maximum will tell you about the spread of the data. That means if there is a massive spread, that you will understand. Wait a minute. Let's look at the variable 100. Let's first look at the blood pressure variable, where 123 is the mean and the variance is 185. As I explained earlier, this data has significant over dispersion, where the mean is less than the variance. If you look at any other variables in this data, is there any other data that has over dispersion? Can you tell me? There is one more variable that has over dispersion. Can someone please unmute and tell me?
Test score?
Test score.
Yeah, the variable test score also has over dispersion, where the mean is 79 and the variance is 89. So whenever you use variables like blood pressure and test scores in your data, for your analysis, especially when you are using linear regression models, you are likely to face something called heteroscedasticity due to the presence of extreme values. Okay, so this is something that you should know about the descriptive statistics, and these are all these variables are here are the scale variables, and for nominal variables or for categorical variables, we use something called frequencies. For that, you can go to analyze, go to descriptive statistics, and select frequencies, where you can add all the nominal variables, that is group, gender, recovery, and diet type. And in statistics, you don't need to add anything, just keep it as it is. Because even if you add mean, median, and mode, SPSS won't give you any output because these are nominal variables. For nominal variables, SPSS won't give any type of statistical values. It only gives you the frequency as well as the percentage. Okay. Select all the nominal variables and click OK. Here, the SPSS will give you multiple tables for multiple factors. First variable is group, and group has two categories, that is control and treatment, where 48 observations are control and 52 observations are treatment, and the respective percentages are given in the next column. So similar to the table above, similar to group, gender also has two groups, that is male and female, and it has 53 male and 47 female, and the respective percentage is given in the next column. So this is how the frequency tables are given. There is not much to interpret in the frequency tables, but before doing any sort of analysis, before doing, especially when you're doing papers, you have to introduce your variables to the readers. So you use descriptive statistical techniques like frequency tables, mean, median, variance, etc. to explain what your variables are, their characteristics. Only then you can justify what type of techniques that you are going to use in your model for inferential statistics. Okay. Is there any doubts regarding this?
So this second one, can you repeat it? I mean, all those categories. I have a confusion in the categories. Like in the
Yeah.
frequent earlier, it was the mean, median, and now we are
Yeah.
shifting to the frequency.
Yeah. Because
And
we
in
are.
frequency, which all, yeah,
Go on, go on. Hello?
yes, sir.
Yeah, please go on. Please finish your question.
Sir, I'm just asking. I have a doubt that in the frequency, what all are the variables that we have to look up for the frequency?
Yeah.
I mean, for the
frequency, we
output
have
as frequency, yeah.
Yeah, for frequencies, we have to select the
Nominal.
See, the nominal variables have this triangle-like icon. You can see here, right? In the variables column, you can see that all these variables selected have a triangle-like icon, right? That means they are nominal variables.
Okay.
Okay. So, if you
And they
select
will be
only-
automatically be generated.
yeah, they will automatically be generated like this.
No, I mean, even in the, we have to just click the frequency. Before that, sir, just back it. Yeah. We have to
Yeah,
go
okay,
for this.
fine.
Yeah.
Analyze descriptive statistics and
Yeah.
frequencies.
And
You
frequency.
mentioned you have the selection process, right?
Yeah.
Yeah, you have in the left side you can see the variables, right? The blood pressure
Yes, sir.
group, test scores, etc. You
Yes,
have
sir.
to select only the nominal variables by clicking here, and if you
Okay.
click the arrow, or you can
Okay.
drag it like this.
Mm. So,
Whatever you want.
yeah. So for frequencies, we have to go for the nominal variables, and all those in the triangle that are supposed to be generated.
Yeah.
Okay.
Okay.
Sir,
Ah.
sir, one, sir.
Okay. It's audible. Hello.
Sir, why are we doing this frequency table, sir?
So, because we have to introduce our variables, right? We want to know how they are distributed. So through frequency tables, if you want, there are suppose in the variable group, you can see the variable group, right?
Yes, sir.
The table. So there are two categories in the variable group. One is control and another one is treatment. Before doing any sort of analysis, we must know that how they are distributed, how many samples are there in control and treatment. Only then we can say that. Only after that we can go for analysis. If one category has more variables than the other, sometimes our results may not be biased, may not be correct. It may be biased, right?
Yes.
If suppose there are 90 samples in treatment and 10 samples in control, here we cannot do a meaningful analysis because there will be bias. One category has more samples than the other. So before doing our analysis, it's important for us to know how the variables are distributed, how the categories are distributed, right? How many samples are there in each categories. Only then we can tell this analysis is suitable. So that's what descriptive statistics does. If you refer any paper, if you refer any thesis, you will see that the first analysis they do is the descriptive statistics. That's because so that the readers could know what type of variables they are dealing with. Okay.
Okay, sir. Thank you.
So we have to, while giving the descriptive analysis, we have to write it also. I mean, we have to
Yeah.
analyze it also.
We have to explain it, right?
Explain it.
The explanation will be done using the percentage. You don't need to quote the frequency. There are 52% people in treatment group and there are 48% people in control group. Just describe what's in your table. That's it.
Okay, sir.
Okay.
Sir, this is like percentage analysis what we do, right?
Yeah, this is simply the percentage analysis.
Okay.
Okay. So, after the descriptive statistics, we will go towards the inferential statistics. Inferential statistics means we are estimating the population using our samples. That means the usual logic is we cannot collect data from the entire people. So what we'll do is we will collect data from a few people randomly.